All right, this is Notes 9-1, Part 1. We're going to do this in a 3-part series, so we keep it nice, quick, easy. First things first, if there's nothing there, meaning on the radical, we know that as a what? As a 2, a square root. So if you want to put your 2 there, if you want to get in the habit of so you can see that difference, or if you just got it down, then you don't have to worry about it. But if you wanted to see why, we've been doing those forever. We just do our tree, right? 48 breaks down to what? Go.
2 and 24.
Many things, but you could do what?
2 and 24.
2 and 24. But you could have used 4 and 12, so, all kinds of stuff. It would all come out the same thing. 6 and 8, yeah. Okay, 24 breaks down to 4 times 6, right? 4 is 2 and 2, 6 is 2 and 3. Okay, we're looking for pairs. All right, remember Nike? I said Nike shoes. You got a pair of shoes. You bring it out. Any singles we put back in. If I bring out more than one thing, I multiply them together. If I put back in the box more than one thing, I multiply those together. So I circle pairs at the end of the tree. Here's a pair of 2s. Comes out of the box. Okay. Then I have another pair of 2s at the end of the tree. Comes out of the box. So I multiply those together. That leaves me 3 inside the box. 2 times 2 is 4, square root 3. That's what we've been doing. That's what we're used to. That's stuff that we have. Okay, we haven't done one like this year. You guys have probably done them in the past. This may be a review for a lot of you. This is saying we're not looking for pairs anymore. We're looking for groups of 5. So I start breaking this guy down. It breaks down to what times what? 8 times 8, which would have been great if we were looking for pairs. I would have been done. Okay, that one breaks down to 2 times 4. That breaks down to 2 times 2. Same deal over here. 2 times 4. 2 times 2. Now I start counting the ends. 1, 2, 3, 4, 5. So it comes out as 1, 2. All right, and it leaves me what left over? A 2. It goes back in the box. 2 square root of 2. 2 fifth root of 2. Boom. Sorry, got me. Got to put the 5th root back on it. So this right here tells me, like that one told me to look for pairs. This one told me to look for groups of 5. Okay, then you have to put that 5 right back on your answer. It's not a square root, it's a 5th root. Okay, this one here is a what root? Square. There's nothing there, so I can go ahead and put it on there. Alright, 18 breaks down to 2 times 9. And that one breaks down to 3 times 3. How many m's is that? That's 3 m's, right? So it's m times m times m. We agree? So if I'm looking for pairs, there's a pair, comes out. There's a pair of m's, comes out as 1m. Okay? They multiply together, it gives me 3m. What's left over in each one of these groups? I have a 2 and an m. So they go back in the box. There we go. Done. You don't have to put the 2 on there, but if you really wanted to, you could. We know that if there's nothing there, that is square root. This one here tells me I'm looking for groups of 4. We can go ahead and knock out these x's. There's x, 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 x. That's 1, 2, 3, 4, 5, 6. Okay, there's all my x's right there. They live in Texas. Alright, we got this guy here. Breaks down to what times what?
4 and 8.
4 and 8. 4 breaks down 2 and 2. 8 breaks down 2 and 4. 4 breaks down 2 and 2. We're looking for groups of what? 4. 1, 2, 3, 4. So I'll bring it out one time. What's left over number-wise? A 2. It's going to go back in the box. Looking at x's. 1, 2, 3, 4. Comes out one time. And leaves me what left over? X squared. There's 2 of them. Multiply them back together. So that's x squared. What do I got to put out here?
A 4.
A 4. Done. Okay, if you have a negative number, remember when we were dealing with negative numbers, we brought it out as a what? I. That's because we were doing square roots and there's no such thing as a negative times a negative, so it made them imaginary. But if it's an odd number, a negative can exist, correct? Because a negative times a negative is a,
Positive.
and then times a negative is a
Negative.
negative. So it does in fact exist on these, so it is not an imaginary number. Okay, so when I break this cat down, break it down to what?
8 and 8.
Negative 8 and a positive 8. Okay, break him down to what?
Negative 2, positive,
Negative 2 and a positive 4.
and then just 2
And 2 and 2. This guy here, 2 and 4. This guy here, 2 and 2. Okay? We're looking for groups of 3. Alright? So here's one group of 3. Whoop. Right there. Okay, because it has a negative in it, it has to come out as a negative 2. Okay? This guy here comes out as a singular positive 2. So if your group of 3 has a negative in it, you just bring it out one time, just like we normally would, because it's a 3-pack. But because it has a negative, you gotta bring it out as a negative 2. We're still gonna multiply those groups together at the end, and that gives me negative 4. Now we should be kind of getting good at looking at this. How many groups of 3 are in 8 to the 6th power? 2. So I can go ahead and put it down. Is there anything left over?
No.
No. So I don't even need to write those out. If you have trouble still seeing that, you could write out A 6 different times out here and circle both of your little 3-packs. Okay? How about B to the 7th? How many 3-packs can I get out of that?
2.
2. So B squared comes out. Is there any left over?
Yes.
Yes, there would be
1B.
1 left over. So a B left over. There are no regular numbers left over, right? I've used them all up. And that was the only one of those. What goes outside on here?
3.
3. Done. Okay, this guy here, I'm looking for 5-packs. Okay, so, and with it being an odd number, I know I can have a negative. So it is not an imaginary number. So I'll start breaking this guy down. What times what?
2, 16.
2 and 16, one's got to be a negative, so you don't have to, which one, it doesn't matter.
Negative 2.
Negative 2 and a positive 16. Okay, that one breaks down to
2 and
2 and 8 or 4 and 4 either
8.
way. Okay, it'll come out to the same answer either way. And we're looking for a 5-pack. 1, 2, 3, 4, 5. I used them all, but because it was a negative number involved, it has come out as a negative 2. Okay? How many 5-packs can I get out of X to the 5th?
1.
Just 1. Nothing left over. How many 5-packs can I get out of Y to the 10?
2.
2. Nothing left over. Okay? There is no square root or 5th root in this case. That is it. That is all. Boom. That is the 5th root of all that. Looking for 4-packs. There's already a negative built in, so I know my answer has to be a negative regardless. Okay? But it's an even number, so if it had been inside, we'd have an imaginary number. So 256, I'm going to throw my negative out here. That's going to be in my answer. 256 breaks down to all kinds of things. You choose. I use 2. Start getting it
Sure.
smaller. Because it's an even number, we know it goes down, right?
4 and 64.
So, you said what?
4 and 64.
Oh, he wants to go 4 and 64. So negative 4 and a 64.
Why does it have to be negative?
I'm sorry, I lied. You are right. Thank you for calling me out. That is a positive number. So 4 and 64 is beautiful. Okay, 4 I break down to
2 and 2.
2 and 2. 64, 8 and 8. 8 breaks down to 2 and 4. 4 breaks down to 2 and 2. Same thing with that 8. 2 and 4. 2 and 2. We're looking for how many in a pack? 4. 1, 2, 3, 4. There is one 4-pack. Bring it out one time. 1, 2, 3, 4. There's another 4-pack. Bring it out one time. And that's it. That's the end of the tree, right? There's no variables involved, so negative 2 times 2 is? Negative 4. Final answer. Done. So your assignment for part 1, do not rip it out because we will add to it tomorrow, is A9-1. We are doing 1, 3, 7, 11, and 14. Okay, this is part 1, and we will add to that tomorrow.